Hello, this is Adam Williams. I'm presenting a paper titled Understanding Gesture and Speech Multimodal Interactions for Manipulation Tasks in Augmented Reality Using Unconstrained Elicitation. This work was done by myself and Francisco Ortega at the Colorado State University under the Natural User Interaction Lab. In the near future, optical see-through augmented reality may become pervasive, and with that, understanding novice users' interactions in augmented reality environments is becoming increasingly important. This work steps towards providing a greater understanding of this interaction space. This understanding is gained through running a multimodal elicitation experiment. This experiment tested three modalities of input independently, those being gesture alone, speech alone, and the combination of gesture and speech. In this experiment, participants were shown animations of reference in an optical see-through augmented reality display. They were told that they should guess the interaction used by a fictitious person in another room that triggered the animation. When participants arrived, they were shown video instructions for the experiment and practiced one referent for each modality. The modalities were shown in counterbalanced order with the referent for each modality randomized. For each referent, an animation of the intended effect was shown, however, no text or verbal description was given. In this slide, this is shown as the starting location on the left and the ending location on the right. For this referent, which was move left, the cube would move left over a period of 2 seconds, showing animations allowed the speech results of this experiment to be unbiased by text or audio priming. Between each modality, the NASA TLX was administered. This experiment used 17 referents, which included translations on each axis, rotations about each axis, scaling up and down, the creation and destruction of an object, and selecting an object. Our research aims for the gesture modality of this experiment were together the hand poses used, common gestures that were reused, and common gestures overall. This slide shows the common hand poses on the bottom left and the common gestures that occurred during the course of this study. The translation gestures that occurred most frequently were direct manipulations where a user's hand would match the surface of the cube and then push it in the intended direction. Pitch and roll were both achieved by similarly grabbing the cube and rotating it with the clockwise or counterclockwise motion of a participant's hand. However, yaw was done with an indirect gesture where a participant would point towards the ceiling and then rotate their hand in the intended direction. The hand poses we encountered most often were open hand, grabbing, pinching, and an extended index finger. The most prevalent indirect gestures we found were the bloom gesture found on the HoloLens 1 and the enlarged shrink gesture used for zooming on touchscreen devices. The next two slides use the same graph. This slide is of the gesture proposals from the gesture-only block, and the next slide is of the gesture proposals from the gesture and speech block. In this graph, proposal frequencies are denoted by color, with darker color indicating more proposals. Across the x-axis are the referent used, and on the y-axis are the textual descriptions of the gestures proposed. By looking at the rows of this graph, a sense of the reuse of gestures can be gained. For example, the bloom gesture was used for create, delete, enlarge, shrink, and select, although it was most commonly used for create and shrink. The columns of this graph show the proposal space for each of the referents. Note that any proposal that was suggested by 2 or less participants has been removed. The two major things that can be gained by looking at the columns of this graph are which referents had proposals that were highly clustered and which referents had more disagreement among participants. An example of a highly agreed upon gesture is found in the roll clockwise and roll counterclockwise referents, which are fairly dark and were both grab and circle on X. An example of a referent with more confusion is the shrink referent, which had many different proposals that were all relatively similar. This graph represents the gesture proposals from the gesture and speech block. By looking at this graph, trends in the gesture proposals can be seen. When compared against the gesture alone modality, these trends are largely more disagreement for the abstract reference, shown in the create and delete column having more color cells, and higher agreement in the translation reference, seen prominently in the move left and move right reference, which became much more dark and more consolidated. The main goals of the speech modality of this experiment were defined the syntax used and the utterances used across both the speech and the gesture and speech blocks of this experiment. The proposals found for speech were largely similar. They had moderate agreement rates. Translations were almost always saying move in the direction of movement. Rotations were similarly rotate in the direction of rotation. However, for rotations, this was very ambiguous because the command for roll left and yaw left might both just be rotate left, which is where the gestures and speech combined help because the gesture could disambiguate the speech. This experiment just used animations to limit the speech priming. However, these animations caused difficulties in the abstract reference where participants had to interpret the animation. This was seen mostly in select referent, which was often referred to as highlight, even though it was intended to be select. This slide shows the syntax by condition for speech only. Most commonly, people would just say the action and a direction, so move up. Occasionally, people would just say an action, which might just be move, an action, object, and direction, which means they specified the option, so move that up or move the cube up. Sometimes it was just the action object, move cube, and sometimes it was just the direction, so up. The syntax changed slightly for the gestures and speech block, where action direction occurrence is decreased and transitioned to more action alone, often paired with a gesture indicating the motion. So it might just be saying move and then pointing in a direction. The goals of the gesture and speech modality were to find the timings by phase of interaction and the utterances used, as well as how these interactions changed across blocks. This slide shows the timing of phases of interaction from when gestures start. The phases were gesture start, the first visible motion of a participant's hands; stroke start, which was the first change in direction, often cited as the start of the information content of the gesture; speech start, which was the first audible noise from a participant; stroke stop, and speech stop, which are where the gesture or speech stopped. These results are interesting to us because they show that the stroke, the information content of the gesture, and speech are very closely aligned, seen by the second and third bar up from the bottom. They also show that speech often precedes gestures, and that is often by around 81 milliseconds. These results indicate that watching for large motion changes in gestures produced may indicate when speech can be expected and when the information content of both the gesture and the speech for the interaction can be found. Thank you for attending this presentation. If you have any questions, I can answer them now, or you can email them to me at adamwill@colstate.edu.